Alright, so here's another video documenting my Arduino Hexapod project. I'm about to tear down the prototyping boards of all the electronics and start to minimize things as best I can so that I can work it all into the body of the Hexapod, because obviously he's on a wooden stand right now, which I'm anxious to get him off of and get him walking. I went ahead and built a little Android app to control it, so it's all Bluetooth and ready to go remotely. I plan to do using a PS2 remote and not use the app to actually control them, but for now this is going to be what I'm going to use. So from here I can set the speed, I control the walking motion, direction, I can control the head. These numbered buttons are just to control a few light patterns that I put in, and then just a few settings and such. So the first thing I like to do is just hit what I call rest mode, so I could store him away like that and he won't hook onto anything. And then he can go back home just to make sure everything's ready to go. So yeah, these number buttons are just a few different light patterns, headlights, and then he has 3 different walking modes. So that's what gait is, which I'll demonstrate in a second. And then this medium is the height of his step, which I'll also demonstrate in a second. And then I have an IR sensor that I'm going to put on board, which is just down on the prototype board right now, that will sense movement and he'll react accordingly. So we'll go ahead and test that right now. So if I turn that on, now if I bring my hand close to him, he's going to see that and start moving. Of course, I just have him take a step, but he can do whatever he wants. At that point, we can trigger. Okay, then I just have some head movements. I won't bother showing you the app in motion, but I can move the head around any way I want. Okay, and then the fun stuff, walking. So here's just the forward. This is, oh, by the way, my back right leg, and this one right here, the coax motor is not connected right now, so ignore that. But right here they move in 2 sets of 3, the legs. This is probably the best gait and the most stable gait. It's referred to as a tripod gait, meaning it's always standing on at least 3 legs. Okay, it looks a lot better with it's sped up, which I can of course do from my remote. Now I'll demonstrate the height. So this is the medium height step, which would be for normal walking. Then he's got a low step, which will speed him up quite a bit, probably almost twice the speed by taking that low step. You can see his legs are not moving up like they were before. And then if he comes across non-level terrain, we can go into a high step, which should help him get over any kind of obstacles that he may encounter. So again, for now, no inverse kinematics. I just manually program these things just so I can get it on the ground, get it walking, get a feel for the mechanics and electronics. And then when that's all said and done, I'll take on the inverse kinematics. So yeah, you can also walk left, which I'm not too sure how will work yet. Basically what's happening here is these legs are actually taking a step. These are barely moving. So it should theoretically turn this way. And then same for the right. And I like to hit this reset once in a while just to make sure everything's in sync. And then he can also walk backwards. So if you can see here, he's kind of doing a backstroke. Hard to tell on camera maybe, but so that's backwards. And that's forwards at the smaller step. So yeah, there we go. My app's done to control it. If I get this thing wirelessly, which I'm now going to pause for a minute and hand the camera and talk quickly about the electronics. For anybody who doesn't care, I'll talk to you next time. So here are the electronics again, which I've shown in one of the first videos. Things have changed a bit, not too much. So I decided to go with Arduino Uno. That's going to work just fine. I'm having no problems. All of these controls are going bye-bye. They're not needed for the actual bot. But let's start here. So the battery, yes, the battery is going to get mounted hopefully to the bottom. Okay, and then this main battery switch will get mounted somewhere. I may go with something smaller, but it does have to be high current. And then next we have the boost buck converter, which will let me control the exact voltage going in, which is absolutely necessary, and it has to be a high amperage one. So this one's rated for 10 amps, which should be just enough for my 20-something servos, considering rarely will they all be fired at once. And then I'm going to have a separate switch on here just to cut the motor power. So the rest of the system will stay powered, and I can just shut off the motors. So that'll get installed somewhere on the body as well. Okay, then like I said, we have the Arduino Nano. This LED strip is going to go bye-bye. There's one on the head with just 2 LEDs, which will stay. And then these 2 meters, or I should say 3 meters, this one I probably won't keep because I really don't need to see the amp drawer. That's really was more for development, and it shows the raw power coming in as well, so it would monitor my raw battery power. However, I have a circuit built, which I explained in one of my previous videos, that is taking the battery power and reducing it down to a ratio down to 4 volts that I could pass into the Arduino, so I can monitor that 4 volts. If it drops below whatever thresholds I have it set for, I know the battery is below its required 11 point something amperage volts that I need to power this whole thing. So anyway, I probably will not keep both of these meters. So this one here is the power going to the Nano, and then this one here is the power going to my motors. That one is the most important, right? Because if my boost buck converter gets adjusted by accident, which by the way I plan to glue that potentiometer in place, if not desolder it and remove it completely, because I have it set pretty perfectly right now. I don't want to push to 6.8 volts. I think 6.6 is fine. But yeah, if you push too many volts, like if I accidentally hit that potentiometer and push that to 10 volts, bye-bye servo motors. So yeah, that gauge I will most likely keep, that display. The Arduino one can probably go away. I installed that in the beginning, but since then I've installed a 5-volt regulator to make sure that the Arduino is always getting the power that it needs and not dropping below a certain threshold. Because when that was happening to me, my LEDs weren't working right, or the Bluetooth module wasn't working correctly, which by the way, just a standard Arduino Bluetooth module there that I'm using to connect. And then finally a little infrared sensor that I'm working on this right now. This is a 360 servo, so as long as I can set up the wiring, which I think I already have, I can't really manually turn this for you with one hand especially, but I have it turning about 320 degrees. So the idea here is this is just going to sweep back and forth looking for motion. So yeah, that'll get mounted to the top of the Hexapod. So again, all these switches are going bye-bye. So really I have this board to get on there, onto the Hexapod, the Nano to get onto the Hexapod, the Bluetooth module, one of those displays, and obviously a bunch of this wiring, my battery monitor circuit. This switch will get mounted somewhere. This will probably get mounted underneath along with the battery. And yeah, that's it. Then really the main project is all this wiring. So I actually wanted to undo this, but I guess I might be able to. There's one screw in it. Which I may not have to remove to get to it. Just kind of want to show you what kind of room I have in here to work with. Not much. So I may end up putting components on top, which I really don't want to do. I think that one screw is going to mess me up. So I'm doing this only because I'm ready to tear this thing down anyway and start doing all the electronics. But yeah, I can't really remove it. Sorry. But you can see there's a fair bit of room. I mean, these standoffs that I have are right here and here. So I have a nice big square of space underneath here that I should be able to get the 1, 2, even that one, 3 boards in there. And then a bunch of little electronics. So yeah, that's my project. Once I get that all done, it should be untethered and ready to go for some real world tests. Cool. Thanks for watching.